Okay, let's start the session. So hello and welcome to this session on middleware security, authentication, authorization and auditing services. I'm Divya Mehra. I'm a product manager in the JBoss Middleware division, and I'm joined by Derek Walker from Swift, who's one of our customers of our middleware products, and Vikas Kumar, who heads the identity and access management team at Red Hat. The agenda that we have here, so we have the talk comprises 3 parts. So I would be doing the first one, which is basically an overview of middleware security. We'll just review a few concepts at the beginning and then get an overview of our JBoss middleware portfolio and what security features and use cases does it enable. We'll spend a few minutes on a new web single sign-on service, which is based on a very popular community project called Keycloak that we actually presented last summit, but now it's a supported offering from Red Hat. And then there's a slide on just future for the next 12 months, what is the security roadmap. After that, we will go through 2 case studies. First, Derek would go through a case study at Swift, which uses JBoss Fuse. And then Vikas will have a case study which the Red Hat Identity and Access Management team uses, which is based on JBoss EAP and the new Web SSO offering based on Keycloak. We'll leave a few minutes for Q&A. Okay, so let's start with the first section, just an overview. So why do we care about this session? Security, we surveyed our customers recently, the Red Hat customers, and security is one of the top priority as you would expect for enterprises. It was the 3rd highest cited priority after private cloud computing and data center modernization. But it also represents one of the greatest challenges and risks for the enterprise. So it was rated as the 2nd highest priority for a CIO among the 765 customers that we polled. So conceptually, what do you mean when you talk about information security? What does it, at the core, what does it mean? It's basically represented by a pillar of a triad of confidentiality, integrity, and availability of data. So at its core, what you're concerned with information security is this CIA pillar. That information is not made available to unauthorized entities. That's confidentiality. Data cannot be modified or in an unauthorized or undetected manner, whether it is at rest or is it in transit. And finally, that information must be available when it is needed, provided that the first 2 are satisfied. You want to be, if you are authorized to access the information, you should be able to access it when you want. So how it relates to middleware. So if you look at a typical middleware architecture, you have the clients, which could be a browser, a mobile device, or maybe an IoT gateway. And then you have web services or servlet applications or an API gateway, which comprises your middleware. And then your backend where you store the data, a file system or a database. And you are concerned about the confidentiality, integrity, and availability as the data flows between the clients, the application platform, and the backend. And how do we translate this now, these 3 pillars of properties that we want in our InfoSec? How do we map these at a high level logically into features that you would expect from a middleware product feature set? So for example, authentication, the feature will be authentication, and that basically is about verifying the identity of the user or the entity that they are indeed who they claim to be. So if I'm claiming to be John, then I'm indeed John. So that's authentication. That's a key aspect of confidentiality. And once I'm authenticated, what data can that user or entity be allowed to access? So that's authorization. And that touches upon confidentiality and integrity, as you don't want unauthorized users to access data or undetected, unauthorized people to modify the data. Then there is audit logging, which is a trail for compliance purposes, for compliance and detection to know what happened. That also touches upon confidentiality and integrity. Encryption, which is transforming the data in transit so that it is inaccessible to authorized users. So you would look for encryption support in your middleware stack. Clustering, which is now touching upon availability. So can you have group of independent servers connected via shared network? They're sharing computing tasks so that you can make that data available as needed. And you have high availability and failover characteristics. Another thing that you look for is guaranteed delivery. This is in regards to messaging. And once a message is placed into a message channel, will your message broker or your messaging system guarantee that the message reaches its destination, even if parts of the application should fail? So that's a key consideration in availability as well as in integrity. And finally, digital signing, that touches upon something called non-repudiation. So if you have done everything else and a user has encrypted the data, but the user should not be able to deny that he has sent a message. So do you have features for signing such that a user who has digitally signed a message cannot reasonably deny that he has done so? So that's also an essential aspect of integrity. So these are kind of features that you would be looking for in a middleware portfolio. All right, just skipped a couple of slides. Sorry, the colors have not come out well here, but we also have a NIST framework for securing deployments. This is looking now at your total deployment, not just at the feature set, but how do you view security in your enterprise deployment. That's basically, this is the NIST framework. Are your assets and configurations well known? Do you know where your data is? Are the applications and systems and the products coming from known sources? And that's one of the reasons why you would have enterprise JBoss middleware as opposed to open source components that you may not know where they're coming from. Protection, you have enough controls in place to identify unauthorized access and changes. Your ability to detect when unauthorized access has been attempted or been successful, and then your ability to respond and recover from that, and then it becomes an iterative process. So this is like a high level framework that NIST, if you go on their website, they actually go into fair amount of detail into how to cover each of these points. But at a high level, this framework is what you would look at to protect your enterprise deployment. All right, so this is a little bit of an overview. Let's shift gears a little bit to talk about how you can use Red Hat JBoss middleware to secure your applications and your data. So just an overview of the middleware portfolio. We categorize our product portfolio in 3 pillars: accelerate, integrate, and automate. So accelerate comprises our Java EE app server, that is JBoss Enterprise Application Platform, our in-memory data grid, that's JBoss Data Grid, JBoss Web Server, which is an enterprise version of Tomcat, and the Red Hat Mobile Application Platform. On the integrate, we have our ESB product, which is Red Hat JBoss Fuse, our messaging product, which is AMQ, which is based on ActiveMQ, and our data federation solution, which is JBoss Data Virtualization. And finally, in the automate, we have our business rules management system and our BPM suite. The middleware portfolio is supported both in physical and virtualized deployments. So you can run it on Linux, or we also support these products running on OpenShift Enterprise. So you can run it on a private cloud. We also support running this directly or via OpenShift Enterprise on most of the leading public cloud providers. All right. So let's take a little bit of an overview of how does Red Hat JBoss middleware helps you become secure. If you talk about the NIST framework, how does it help you to be secure? So one of the key advantages that you get from JBoss middleware are fully trusted open source systems in your middleware deployment. So we build our products from source, so we know where every component is coming from, build it from source, and therefore our customers can trust that the open source components that they're getting from has already been vetted by Red Hat and has been warranted, you can trust that where it's coming from and the source of it. We provide proactive security advisories and fixes. That's part of the Red Hat subscription to help keep your system secure. So we're proactively looking for CVEs, for example, and we also actually publish metrics on which can be queried by time or product line publicly that you can check which CV or which security errata we release for different products from our website. And finally, as regards specifically JBoss middleware, which is mainly based on Java, it's written in Java. So we rely on open standards as much as possible for all our security components, so that then these standards, since we are using the standards, we can benefit from the wider ecosystem. So we always believe in using standards to the maximum extent possible. So specifically for cryptographic algorithms and frameworks, we rely on those functions from the underlying JVM as much as possible, so Java SE. For authentication, we rely on standards like SAML 2.0, Kerberos, or OpenID Connect, which is new, which is based on OAuth 2.0. We'll go into some detail in later part of the section. And then transport layer security for transport security, and WS security stack for message security. This is applicable throughout the product portfolio. We not only rely on Java SE, but we actually support it. So we support OpenJDK, and OpenJDK is included with your Red Hat Enterprise Linux subscription. And for example, currently we are supporting Java SE, so OpenJDK 7 and 8, and we support it for a longer life cycle than the public Java SE updates that Oracle provides. So for example, for Java SE 7, we support it up to June 2018. For 8, we are supporting it until October of 2020. So in addition to all these cross-cutting things that we do to help with security, let's talk a little bit about the features, just to give you an overview or flavor of what are various features that our products cover. So if you look at our main flagship product for middleware, which is the JBoss EAP, it relies on Java EE and SE standards. It is secured by default. It does not ship with a default password, for example. And it has JBoss EAP 6 has a modular, 6 and 7, 6 onwards basically has a modular architecture where it only loads the modules that are required at runtime. We also added role-based access control and audit logging for administrative operations for compliance and auditing purposes. JBoss Fuse supports the standards for WS security and all the WS star stack via the Apache CXF Web Services Framework. For guaranteed message delivery, we support that via Apache ActiveMQ in both JBoss Fuse and even in AMQ. And we have role-based access control through the Fuse management console for JMX connection, as well as the Karaf command console. If you look at our data products, that's JBoss Data Grid, our in-memory distributed caching or in-memory data grid. That provides you role-based access control to cache managers. Since it's a distributed system, there is node-based authentication and authorization whenever a new node tries to join the cluster. We have that. And we also have the ability to encrypt the communication not only between the client and the cluster, but also within the nodes of the cluster for security. We have a very detailed presentation on this topic from last summit with the URL there. Data virtualization is basically a data federation solution which allows you to federate through multiple disparate data sources using a SQL-like interface. And that has role-based access control, fine-grained role-based access control to create read, update, and delete operations across the various data sources. So from a single centralized point, you can control role-based access control in a fine-grained manner to these data sources. That includes row-based and column-based masking of the data. You can also centralize the audit logging for data access operations. So imagine that you have dozens of data sources, and instead of relying on the audit logging of each of these disparate sources, you can centralize that with JBoss data virtualization. And finally, in the BPM suite, we have role-based access control at the organization, repository, project, and package granularity. And we have, for rules as well as data models, we also have comprehensive audit logging, both for admin time and runtime operations, so that at runtime you can know which rules were executed, who executed that, and what data was used in the decision making. So this is pretty useful for compliance that our customers are using. So some applications that these features can be used for real-time fraud detection. It's an architecture where if you want to detect credit card fraud in real time, You can use BPM Suite with AMQ and Data Grid together to form a solution for this. Like we discussed with JBoss Data Virtualization, centralizing the security of the data as well as the audit logging across multiple federated data sources. The ability to store and process personally identifiable information in memory, so you get the benefits of in-memory computing and the high performance, but also without compromising on the security of the data. And finally, web SSO authentication, identity federation, single sign-on, that's JBoss EAP and Keycloak. We'll actually go into more detail with one of the case studies today. Okay, so I'll just switch gears to talk a little bit about our new single sign-on service, Keycloak. This is a very popular product, and the objective here is to provide a consolidated web single sign-on experience across our entire product portfolio. So this is not just going to be applied only to JBoss middleware, but we are also going to have our platform side products, the Linux side products, use this offering for federation and single sign-on. So and also the second objective here is to use the standard SAML 2.0 and OpenID Connect, which is based on OAuth 2. So the architecture here is your Keycloak, your single sign-on server mediates between your enterprise backend, which stores the user or identity information, and your applications, which act as service providers, which use the standard-based token to then make authorization decisions. What do we include in this? This can be a talk in itself, but just to give you a very quick summary, we gave a presentation on this last summit. Now we have an enterprise fully supported version of Keycloak, which was just released on June 16th, so just a couple of weeks earlier. And it's available as a zip distribution with RPMs planned. The 7.0 was the first release, and the next release, 7.1, will also plan RPMs for it. It's a standalone server that can be used as an OpenID Connect based or SAML identity provider. There is a very good, easy to use administrative UI and REST APIs to be able to do client application registering and role mapping. And it can also act as an identity broker. So instead of just talking to the enterprise backend for the source of identity information, it can also talk to a social network like Facebook, Google, and Twitter, or a third-party SSO provider, a SAML IDP, and you federate across that. This is just a screenshot of the user interface. All right, so in addition to the server, you also have client adapters, which are basically service provider side modules. So we ship client adapters for both OpenID Connect as well as for SAML, which is for EAP 6.4 and certified with EAP 7. We also have a client adapter for JBoss Fuse 6.2, but that's a tech preview. In the next release, we plan to make it fully supported. It is already certified with JBoss BPM Suite 6.3, so it mediates authentication for Business Central, the intelligent process server, and third-party clients in JBoss BPM Suite 6.3, which was released a few weeks ago. And finally, it is certified as a SAML IDP with the mod.melon module, which is included in Red Hat Enterprise Linux 7.2. So this provides an integration point with all the infrastructure products that are layered on Red Hat Enterprise Linux. The entitlements, this is a distribution, a standalone distribution, and all the products will integrate with it. So as a customer, you just need to install the SSO server once, and then you can connect all your products to use this one identity provider. And then all the bug fixes or security errata, you just have to apply it to a single set of bits. It has a 3-year support cycle initially. That's our support lifecycle page where you can get more information, but it's supported in a 3-year lifecycle. It doesn't have a separate SKU, but it is included in the newly formed JBoss Core Services collection, to which you will get entitlements with most of the middleware products. So if you're a JBoss EAP or a JBoss Fuse customer or BPM, you will have entitlements. You will get support for single sign-on also via RHSSO. And soon in July and August timeframe, we are planning to introduce this as a platform service for OpenShift. So both for application level as well as administrative level security on OpenShift, and also as a SAML identity provider for RHEL OpenStack. So that's a first platform product that's going to be using Keycloak for identity management. All right, so this is probably the last slide, just to give you a flavor of what we are planning for the next 12 months on the middleware side in terms of security. So currently JBoss EAP 7.0 was just announced in Summit, and we are working on JBoss EAP 7.1. And one of the key new features of that is the Electron security subsystem that we would bring to market in EAP 7.1. So that would provide you a single subsystem for configuring management as well as application security. It's the next generation of Picket Box, and what will allow you to do is like configure SSL and all those security related things at one place instead of in each and every module, which you have to do separately now. It will also provide a public SPI to plug in custom components. For example, if you want your own custom authentication mechanism, for example, if you want to delegate authentication to Keycloak, you can do that via a public SPI so that you can have management level SSO using Keycloak. The other thing that we're doing is on the certification side, common criteria certification would go into JBoss EAP 7.1. In Red Hat single sign-on, that's Keycloak, we are working on 7.1. Although we are based on OpenID Connect, we haven't formally certified it with the OpenID Connect conformance profiles. That's on the roadmap for 7.1. And if you have attended any of the platform side sessions, then we will also be integrating, having an SSSD integration with RHEL IDM, which will allow you to use Active Directory for us that's provided by RHEL IDM. For Node.js developers, we would introduce a Node.js client so that you can use Node.js, your application as the service provider. And we will also introduce integration with Red Hat Mobile, CloudForms, data virtualization, and as well as Ansible. So, and finally, API management. So we recently, in fact, last week acquired 3Scale. So one of the key roadmap items for the next 12 months is to integrate API management with the rest of our product portfolio. Okay, so that finishes my part of the session, and I will now hand it over to Derek from Swift, who will go over a real case study with Swift using middleware. Hi.
Okay, excuse me, can you hear me? Okay. So I'm going to change gears a little bit. We've been talking a lot about products. I'm going to talk more at an application level, and actually the level is going to be integrating. How do you secure integrations between systems and Fuse? We're going to first start off talking a little bit about what does it mean to secure financial messaging, but this could be applied to any messaging in general. We'll then take a look at what is the nature of integration and what needs to be secured. And then we'll talk a little bit about enterprise integration patterns, EIPs. And those are very important because those are something that's very core and fundamental to Fuse. Then we'll take a look at securing data at rest, securing data in flight, and then I'll go through about 4 EIPs that I think are very important for trying to secure any solution. And then finally, we glue it all together, we have an end-to-end example. So, no talk would be complete without a good joke or something, right? So for those of you with gray hairs know what Dilbert is. Let me just read this out to speed this up. When I started programming, we didn't have any of those sissy icons in Windows. All we had were ones and zeros, and sometimes we didn't even have ones. I wrote an entire database program using only zeros. You had zeros, we only had the letter O. So this is not going to be one of those talks, but what I am going to try to do is let you know some of the stuff that we've learned, how we've stubbed our toes a few times. And it's a very short talk, so it's going to be pretty much a drive-by. We're not going to get into a lot of specifics. I'm going to give you some overviews that you can do a little bit of research later on. Okay, so Divya talked already about the 3 pillars of security. I'm going to talk about an enhanced version of those. So he talked about them in the general sense. I'm going to talk about them as applicable to communications and to message exchange. So of course we have confidentiality. We mentioned about the unauthorized access to data, but I'd like to extend that to also unauthorized access to your protocol. So if a hacker can see how you're establishing sessions, how you act messages and things like that, then he has a way of knowing how to spoof and how to hack your system. Integrity is not only the integrity of the message to make sure that it's not been corrupted while in transport by communication issues, but then something hasn't been maliciously done to it. There's also the idea of, is it the whole message? Is it guaranteed delivery? Are there transactionality involved? So there's a lot of components that make up the whole integrity side of it. And then of course, Divya mentioned availability. So the service needs to be up, it needs to be callable, you need to be able to exchange data. So we'll talk about these as aspects that need to be addressed when you're looking at your solution. So the nature of integration. So does anybody know the definition of a legacy system? Since we don't have a lot of time, I'll tell you the answer. Anything in production. So I know that a lot of you guys are rolling out stuff on a many deployments a day, but there's a whole world where things have to be regulated, have to be certified. And so, the idea of just fixing a system to support some kind of a secure integration is not always practical. That's why I say integration is pragmatic. So you're going to have your ideal, hey, I want this cool SOA or microservices-based architecture, but the reality is you got some mainframe who's producing a batch file every day and you have to consume that. So when you look at integration, there's really just two aspects. How do you get the information back and forth, and what is it that you have? And those two aspects, if you take a look at that, that's what you need to secure. And a point that really I think is pretty neat is that you can actually apply controls to less secure systems if you do have a middleware layer. So you may have a system that doesn't have all that controls, but you can actually kind of isolate it and apply controls on top of it to make it more secure. And we'll talk a bit later about how some techniques to doing that. Okay, has anybody read this book? So I know all the integration guys in the room. So the beauty of this book is this is kind of the formalized best practices of doing integration. It's how you learn the craft. The other big benefit of this is Camel implements a lot of these patterns natively within the code. So you don't have to build a lot of these patterns. They come for free within the product, and to call them is literally a single line DSL call. So that saves you time, but more importantly, it also saves you testing and worrying about issues down the road. Okay, data at rest. This is a big vector of attack. So once you have data on disk or that is stopped, then a hacker can take a look at it and try to figure out what to do and how to compromise it. That risk is proportional to the time that it's at rest. So the longer you have something sitting around, the more exposure it has. To deal with this, you often need multiple controls. It's difficult to secure, going across many domains. And then once you do figure out how to do that, now you have to worry about availability, right? So, and how am I going to replicate this to my DR site? Is it going to be timely? Am I going to lose data? What about transactions? So in general, we try to avoid doing any data at rest, have a direct system-to-system, secure network messaging-based exchange. However, back to my pragmatic side, sometimes you don't have that choice, and sometimes that isn't the best architectural choice, right? So maybe you want them to be decoupled. Maybe you want it to be async. So you need to, kind of weigh the options. And if you do have to put it at rest, definitely recommend to do some type of queuing system like ActiveMQ, right? The stuff's already built for you. You don't have to roll your own. Now we'll take a look at transport layer security, so data in flight. The first thing you're going to have to do is try to figure out what kind of a secure protocol you can use to that system or that application that you're interfacing. Camel comes with tons of pre-built components, so you don't have to build these. I gave you a list of them, some examples here, there's many more. Then once you get it, it's not sufficient just to have a secure channel. Now you have to make sure that who's ever invoking that secure channel is actually somebody you trust. So now you get into the authentication piece of it. Luckily, a lot of these protocols already have authentication built in as part of it. But if you don't, you can do something that's called an HMAC, which is a hash message authentication code. And what that does is it not only secures the data that's coming across, but because it involves a secret, you know that who's sending it knows that secret. Therefore, you have a strong indication that that's the person who sent it. And you can do other things like IP whitelisting. Now, if you can't go through the first two pieces and maybe have a unsecured way of getting data back and forth from your other system, then you can look at payload encryption. And payload encryption, as Divya was talking about before, you can get confidentiality there, you can get authentication if you're using things like public PKI, and it also ensures integrity, because if you decrypt it and the message is valid, then you know that you have a good idea that nobody's messed with it. Camel, again, saves you on this because they have the idea of data types. And within the DSL, you can literally say marshal and unmarshal in and out of certain encryption algorithms. And I'll let you go to the Camel site to go look it up, or the Fuse site to go look up, see what's supported. But there's also a Camel crypto library that has a number of crypto functions already pre-built for you. And again, you can just call them from the DSL. Everybody says this, and I'll say it again, don't roll your own crypto. Use a real, a third-party verified library. And then finally, I was going to talk about authorization. So here's where we're getting a little bit into API management, but you can add another control on top of all of this to say, oh, well, this client really is only allowed to call this service, and they're only allowed to call this service between this time. So you can add yet another restriction or control on that communication layer so that you can make sure that you're locking it down. Okay, here's my two favorite EIPs, enveloping and the canonical data. So the concept about an envelope is, remember I hinted before that you can actually add more security on a less secure system. So the idea of an envelope is you can create a bunch of data elements, you group them together, create a header, wrap that around your payload, and now you can put security-specific data elements in that header and use that as a way to authenticate or authorize certain services. You have the other benefit of actually within routing, within Fuse, you can then have elements that you could route on, that you could make decisions or logic as to how you process that information. The actual data itself, one of the techniques that we found to be extremely useful is starting to look at the idea of canonical data or an abstracted data model. So instead of having each of the back-end systems implement standard specific messages and understand how to build those and deal with the versions, you come up with an overall data architecture model in which you create, dare I say, data objects that represent, say, a payment or an order, and then you use those in a very simple syntax, and those are your messages of exchange. And so the back-end systems don't have to worry about what standard it's communicating with or receiving from. It doesn't have to worry about versions. And then the nice thing about it is now you have a way in which you can apply universal or standardized controls on top of that data. So because you're always representing, say, a client in a certain way, you can apply the same kind of validation rules to any kind of client that comes through there. And to start off with that, you don't have to roll your own again. There's some enterprise data models already out there that could be used as a starting point, and actually these are more messages, but you can use the elements from that, simplify them to make your own. And for the financial services space, you have ISO 20022, and in healthcare, you have HL7. There's, I'm sure, others in other domains. Here's an example of it, and as you can see, this is in XML. There's no reason why this couldn't be in JSON or some other syntax. But the idea here is, here I have my canonical header. I have things of who's actually sending the message, what service are they trying to evoke. Here's some security, so I've added a SHA-256 HMAC to the header, and then I have some other metadata that helps me process it. And this you can do that's all outside of the actual payload, which is the data itself. And then the data, as you can see, is very simple. Any source system can understand this and can build this quite easily. And then okay, let's get through this animation here. Forgot to take that out. Then once you have your canonical message, then based on logic, you can transform it into whatever standard you need to. And one of the real benefits to doing that is then you can create a center of expertise that understands that standard and how to take it from canonical to that standard. and not have to worry about putting that knowledge in each of your sending or consuming systems. So you have lots of bugs there, lots of expense in maintaining that. And then finally, once you get the message created to go out, then we use the pattern of the channel adapter, and that adds transport and network-specific information to the message before you send it out on the network. How does that look when you glue it all together? Well, this is kind of a typical system pattern that we do. So you'll have a system, you'll have some guaranteed message delivery, and that could be ActiveMQ, it could be a secured messaging standard like some web services. You have a gateway here, and it kind of multiplexes all the feeds coming in, and then it handles the envelope. It looks at what the envelope has, verifies that, you know, this is something that can be, a service can be evoked, invokes the service, and then from there you have a transformation to the channel adapter and then out onto the network. And we do those with Fuse and ActiveMQ. That's the drive-by. Hopefully you'll get something good out of it. Now we'll turn it over.
Thank you, Derek. So this case study is about the identity provider that we have implemented using Keycloak. Before I start, I want to highlight on why we needed identity provider and what is the use case behind it, what are the requirements behind it. So we have like around 25 to 30 applications, web applications that needs security, right? They can only allow people or customers to access protected content once the customers enter the credentials, username, and password. So instead of the option one is like all the applications implement their own security mechanism, or we have a central identity provider which serves these applications, and these applications don't have to worry about how they're going to implement their security. Second use case is like if you have logged into one application, you can log into the other applications without entering your credentials again, basically single sign-on. So that is the basic theme behind us implementing the identity provider, and we have implemented using Keycloak. There are some other specific use cases. For example, at Red Hat, we have applications. Some applications just have email address and password, and you can just breeze in. There are applications where you need to provide your complete information while you are registering as a new customer, like your address, your phone number, your username, email address, password, etc. So this identity provider should be able to deal with both these kind of users. You should be able to log in with your login address. You should be able to log in with your email address. There are situations where customers have different accounts and both of them have same email address. So this identity provider should be able to handle that situation as well. We are not using Keycloak as the verification mechanism in the background. Rather, we have like different services, like there is one legacy service, there is one new service. So whenever a customer tries to log in, Keycloak, what it does is it talks to that legacy service or that new service that we have built to check the credentials of the user if they're valid or not, to fetch the roles of the user from those services. So we have different sets of services in the background that we have to deal with. Then for registration, like when new customers comes and try to use our website, there is a different application, and where we are not using Keycloak registration. We have third-party IDP that we need to support with this new IDP that we have built. We have user impersonation. That means customer support can get into as a customer and try to help fix the customer issues. We have a centralized terms acceptance. There are certain terms needed by different applications, and those are centralized with our identity provider. We have built our resilient system. I will provide more details about resiliency in the next few slides. Custom and look and feel for our login pages. Failover handling. We have 500,000 customer base. So these are some of the use cases that has led us to implement the Keycloak as the identity provider. Moving next, on the left-hand side, if you see, these are the applications that I was talking about, like we have 25 to 30 applications. And another piece of the puzzle is like you see on the left-hand side, there is SSO bridge application. What that means is all these applications, most of them are tied to that legacy SSO bridge application, which was serving as the SSO for these applications, which was providing cookies, etc., roles, all the information to the applications. And now we have built Keycloak IDP, and we cannot move all these applications to talk to the Keycloak IDP overnight. So we have to have some mechanism such that when a customer comes onto these applications like customer portal, it goes on to the SSO bridge. SSO bridge talks to the Keycloak IDP. Keycloak IDP talks to the backend services, prepares the authentication, and sends the information back to the bridge. SSO bridge prepare cookies and other needed information and tell the customer that yes, this user is authenticated, and now you can go ahead and let him access your protected resource. So that is one set of things. And if you see connect.red.com in the bottom, that is another application, but it is talking directly to the Keycloak IDP. That is where we want to go, but that's how we have been dealing with both type of situations. So these are all our service providers and how they are talking with the Keycloak IDP. If I zoom in on the Keycloak IDP piece a little bit more, so what we have done is like we have built a resilient active-active system where Keycloak is deployed into two different data centers, DC1 and DC2. Whenever a new request comes in to check like if credentials are valid or not, Akamai pushes them to either DC1 or DC2 depending on the availability or which one is the faster DC from the Akamai perspective. And the request goes there. Once it is within one data center, we have load balancers to route the traffic to the different nodes. So we have either 2 or 4 Keycloak nodes depending on the environment. And then the Keycloak nodes are backed up by Keycloak database, which is based off of MariaDB. So under the hood, we are mostly using all the Red Hat products. Red Hat SSO Keycloak 7.1, which has been released very recently, JBoss EAP 7, MariaDB, and then we have like Ansible, Puppet, etc. for building, deployment, all those kind of taking the package to the production environment. So now, what all features that we are using from Keycloak for our identity provider? User federation. User federation has like a lot of flexibility with Keycloak in the sense you don't have to use the Keycloak database for authentication purposes. As I was talking in the previous slide, you can push your authentication to the backend services and you can implement the federation accordingly. SAML OpenID Connect, those are the protocols through how the applications talk to the Keycloak IDP. Client templates. So Keycloak has a client template mechanism where for each client that you are trying to add to the Keycloak IDP, you don't have to build a separate instance of that. You can use the templates and you can build it fast. Browser flows. In the Keycloak admin console, you can have browser flows like for different sets of activities or different sets of situation based on business rules, you can have different types of browser flows. KC eventing system, themes engine, and client adapters, some of the other features that we have used as part of our Keycloak IDP implementation. So while we implemented IDP, what things made our life easier? What has attracted us to use Keycloak, or what we experienced while implementing Keycloak? So Authenticator SPI, that is like there are situations where when a customer or a request comes to the IDP, IDP might have to go to some third party or some other service, right? For example, in our case, terms flow. When a customer comes to Keycloak, Keycloak verifies the credentials, and then what it does is like it will send it to another applications, which is terms application, which will let you acknowledge your terms, and then response will come back to the Keycloak server, and then it will go to the next piece in the chain. It has been really nicely built as part of Keycloak. Before Keycloak, we were using PicketLink, another Red Hat product, but there we had to build a lot of custom code to implement these features for terms flow or anything custom that we had. But here it comes out of the box. Roles, signatures. In Keycloak, you have a lot of options where you can push what kind of role you want to send or what kind of signatures you want to send with a specific application, specific service provider. You don't have to write custom codes to achieve that. So that is another very nice feature that we have seen, because generally, like while we are migrating applications to talk to the Keycloak, application owners would come and say that, hey, I need these two extra attributes. I need email address. I need country code. I need this role. So, and for that, in Keycloak, you just need to configure those, and then you don't need to write any extra code on top of what is already out there. So that is really helpful. Easy to use GUI, extensibility. You can have your user attributes added on top of what is already out there. So these are some of the good features that we have seen that has helped us to accelerate our deployment of Keycloak that we have done in the recently. It's only fair to talk about what challenges we have faced while implementing Keycloak. So the first one is like data replication. So what we have done is, like as in the previous slide you have seen, we have active deployment on DC1 and DC2, and what we were planning to use is to have data among these two data centers be talking to each other, like data are replicated among these two data centers. We were using asynchronous data replication, and while doing that, what we have seen is like we got some replication errors in the situation where like a user is trying to log into both the data centers at the same time, and then Keycloak server is trying to write the same user information to both the database, and then when they're trying to replicate among each other, there were replication errors because of the duplicacy of the data. How this can be fixed? Either we use a synchronous database replication, or we make some changes to the user federation or something on the Keycloak layer. So still we have not dealt with it. As of now, we are not using database replication. Terminating SSL, we are terminating SSL directly at the application Keycloak application node, and while doing that, we realize that there is some kind of ECC and OCSP stapling. These things are lacking right now, so there is some more improvement needed over there. Given that we are supporting 25 to 30 applications in a major, I mean there is a vast user base, it's only fair to evaluate like what is the load and performance of our Keycloak. So when we did this in the lower environment, what we have seen is like what are the parameters? One is the picket link, another one is like Keycloak in DC1 and Keycloak in DC2. So doing the average analysis, what we have seen is there is a improvement of 15 to 20% in DC1 compared to the picket link implementation. In DC2, in fact, there is a slowness from the existing picket link implementation, but that is because of DC2 is trying to have a dependency on DC1 for one of the terms implementation that is not related to the Keycloak, so which we feel we can make improvements upon in the future. So now what we are looking forward, what we want to implement as a next phases for our identity provider, we are looking for social authentication. We are looking for like customer two-factor auth, so we give enhanced security to the customers that instead of static password, they can use two-factor auth as well. We are planning to implement federated logout. We are also trying to merge the IDPs. Like we have different IDPs within Red Hat, and we are trying to see if we can merge those and have a central identity provider which is used by all the applications. We also have another identity provider at Red Hat for associates, and we are trying to see if we can migrate that to use Keycloak as well. And we also planning to implement OpenID Connect and OAuth 2. So thank you very much. This is all we had. I think we are open for questions now.
Just quickly, though, the future plans, these are features in RHSSO, you're just not implementing.
Yes, that's true. Question is like, these features are already part of Keycloak. The answer is yes, these are already part of Keycloak, but we have not implemented as part of Red Hat IT.
Why did that work to migrate from ticketing to Keycloak? How that data mark needs to apply for migrating to Keycloak?
I'm not able to hear you properly. Let me bring my mic maybe.
The question is, what is the level of effort to migrate from ticketing to Keycloak?
So it depends, right? I mean, from our perspective, like we had around 30 applications, though they are talking through legacy SSO, but it took almost 6 months for us to implement or move from Picketlink to Keycloak. But on the scale of small, medium, complex, I would say it is a complex move, maybe because of the architecture that we had. Brian is another person in my team who was part of this implementation. If you want to add something, Brian, feel free to.
Yeah, I mean, most of the problem and complexity was on the service provider side, so having to reintegrate all these applications to a different while and trying to get those various teams to sign off.
And there are so many custom features that we have, like user impersonation. It is part of Keycloak, but we are using like our custom, like we are not using what is coming from the Keycloak. Implement those things. There are certain like cookies, we have to still create cookies out of, because of to support the legacy system. Those things have taken a lot of time for us to implement.
Was there a restriction on the platform? Were you on EAP6 like a client web application?
Yes, client web applications are on EAP. It's a mixture, like some are on EAP6, some are on Drupal. So it's a different sets of application. But yes, from EAP perspective, they're on EAP6.
Even the Keycloak or whatever is running, no restriction EAP6. You don't need to be EAP7, for example.
The Keycloak server is a standalone server distribution. So underneath it has a version of EAP, but that's just implementation detail. So we distribute it as a server that you just start up.
So if I have EAP6, I don't have that. This is not a limitation. I can go ahead with.
Yeah, you would not be deploying applications to the process in which you're running the identity provider. So you can deploy your client applications on EAP6, and we have the client adapters that we ship for that, both SAML as well as the OpenID Connect adapter. So they are in a separate process. The Keycloak server is underneath it is using a version of EAP7, but you don't care about that. You don't really put applications there.
So I have to introduce 7, which I don't have, just for that Keycloak.
You are introducing RHSSO server, so it's a standalone product. So do you have any other questions on maybe Derek's section or my section as well? Okay, thank you very much for attending this session.
Thank you very much, everyone.